You have clicked on OLL. What OLL stands for is orientation of the last layer. So from previous tutorials, you should have built your first two layers by now, meaning this whole layer here is done and this whole middle layer is also done, and what you're focusing on now is the top layer. So orientation of the last layer means that you get the whole top side to be yellow, sort of like this. So as you can see, the whole top side is yellow, but these pieces are not in the correct spots yet. That's called permutation. That will be on the next tutorial. So what we're going to concentrate on now is getting this done. The first step of getting OLL is to first complete a yellow cross on top as if we were doing it on the bottom, but we'll have to use an algorithm this time in order to complete that. After that, from the cross state, we're going to be putting it in full OLL, so the whole top side will be yellow. And we're going to be using an algorithm that we're going to repeat over and over and over again in order to get the cross. And once we're in the cross, we're going to be doing another algorithm over and over and over again until we've completed the whole OLL. So here I've set up a case for you, and there's a few things that you want to look for in order to be able to perform this algorithm properly. What we're looking at here for this whole section to complete the cross is we're not paying attention to these corner pieces at any times. What we're paying attention to is the dot here and these edge pieces. So it doesn't matter. Sometimes you can have a dot like this and nothing in the edge pieces at all. And you might have a yellow facing in this corner, or maybe these two corners, or maybe you just have one yellow piece. It doesn't matter which way it is. We're not paying attention to the corners, just these edges. So in this case, you can see that there are no edge pieces in with it. So that is the first case that we have, and that is called a dot. And when you have the dot, you can perform the algorithm at any angle because it doesn't matter. And what the dot does is it flips some of these edge pieces up, so we're completing part of the cross. And the algorithm for this goes as follows. F, U, R, U prime, R prime, F prime. As you can see, it has now brought the two of these up, so it creates a line. And every time that you have a dot without any other yellows facing upwards on the edge pieces and you perform that algorithm, you're going to end up with this line. Sometimes when you're done the F2L layers, the first two layers, that's what F2L stands for, you might not have the dot. Maybe you will have the line already and you will have to skip the algorithm for doing the dot, which is good. When you have the line, you want to do the algorithm again. And you don't want the line to be up and down. You want the line to be side to side like this. And you complete the algorithm again. F, U, R, U prime, R prime, F prime. As you can see, it's moved one of them from here to here. Now you can see that it's also turned up some of the yellows on the corners, but we're going to disregard those. So you can kind of envision it without those pieces there. And now we've created somewhat of an L. Sometimes when you're done your first two layers, you might skip the dot and the line, and you might already have an L. And that's what we're looking for, is an L shape. Now your L might be down here when you start, and don't let these corners fool you. Don't pay attention to them. We're just looking at these edge pieces next to the centers. And what you want to do is have the L in the upper left, so it looks like an L, but it's kind of backwards, I guess. But this is what we're looking for, and you want to complete the algorithm from that angle, which will finish our cross. So here we have F, U, R, U prime, R prime, F prime. As you can see, it's completed the cross now, and it's brought these two still on top, but that doesn't matter. So after you're done making the cross, there's a whole bunch of different ways that these corners can be. As you can see in this example, when I finish the cross, these two corners have the yellow facing up and these two don't. So we have two in and two out, and there's three different ways that this can look with two in and two out, and we apply the same algorithm in sort of the same way to all of them. So I'm going to go through, I'm going to show you all three of them, and then I'm going to go through all three of them with the algorithm. So there's this one where the two corners that are not upwards are these, and it might be, in the back or the right or in front of you. It doesn't matter, but the yellows are poking out the sides. So if you look at it like this, you can see the yellow pokes out this side and this side. So there's two more where it could be two in and two out, and I'm going to show you those now. This is the other one. It's sort of the same thing where the two out are on the same side, but now these two yellow pieces are in front of us, and we call those headlights when they're in front, because as you can see, it kind of looks like a pair of headlights. And this is the last one that we can have. So as you can see, the two that are out now are on the corners opposite of each other, and if you look at it this way, you can see that the lights are kind of poking out this side. So I've come back to the first case again, and I'm going to show you the algorithm and how to apply it to all three of these. So when you have these where there's 2 in and 2 out after you've done the cross, you're going to apply the same algorithm, and what you want to look for are these yellow pieces that aren't facing upwards, and you want a yellow piece to be in front of you on the left. So this is the way that you would hold it for this case, and the algorithm goes as follows: R, U, R prime, U, R, 2U, R prime. And it has created a cross with just one piece, and that's what we're looking for, is a cross with one piece. So for the second one we saw, where we have the headlights in front of us, again we're going to want to hold it so one piece, there's a yellow in the top left of the face here, as you can see. It doesn't matter that this one's here, as long as there's one in the front on the top left. And we do the algorithm exactly the same way. R, U, R prime, U, R, 2U, R prime. And as you can see, it's created the cross with the one piece, which is what we're looking for. So in our last example, where we have 2 in and 2 out, again, we hold it so there's a yellow piece in the front top left like this, and we do the algorithm again. R, U, R prime, U, R, 2U, R prime. And as you can see, it's created a cross still with one piece in the bottom left. Sometimes when you're done building the cross, you can run into this case where none of the corners have yellow facing up, and there's 2 different ways it can look. Here we have headlights on the left and the right, or in your case, if you're looking at the cube from a different angle, you might have the headlights in the front or the back. The other case that you can see is like this, where you have none of the yellow on the top side of the corners, and you have headlights on the left, but here the headlights aren't here, they've been moved to this side and the back side, and it depends on where you're looking. You might have them on the front right and front left and have the headlights in the back. Either way, when we perform this algorithm, we want to have it so there is a yellow piece on the left side closest to us, just like this, and nothing in front that's yellow. And you want to perform the exact same algorithm. R, U, R prime, U, R, 2U, R prime. And as you can see, it's created a cross with the little dot in the corner, which is exactly what we want. And this is the other case, of course, that we came by where there's nothing on top that's yellow, and we have the headlights on the front, on the left and the right, or the front and the back, depending on where you look at it. And again, the way we want to position this cube to do the algorithm is we want nothing with yellow on top and a yellow on the front left of our left side here. And we want to complete the algorithm again. R, U, R prime, U, R, 2U, R prime. And as you can see, it's created a cross with the little dot here. So now that we've got the cross with the little dot from any of those cases, we only have to perform the algorithm maybe once or maybe twice, depending on how this is looking, to complete the cube. When you have it like this, we always want to place the cross like this with the dot at the front left, just like I have here. Now if you see a yellow piece in front of you here and a yellow piece over here, that means that you only have to complete the algorithm once. So let's complete the algorithm again. R, U, R prime, U, R, 2U, R prime. And as you can see, it has completed this. Now the last and final way that you can view the top after you've completed your cross using the previous algorithms was that, remember with the one we just did before, where we have the cross and we hold this in the bottom left, this piece, and now you can see that this is not yellow, it's over here. And that means that you have to complete the algorithm twice. So I'll show you what I mean. I'll complete the algorithm from this angle. R, U, R prime, U, R, 2U, R prime. And now as you can see, it still has the cross with the piece. So we put that in the bottom left again. And now you can see that the yellow is indeed here and there. And that means that we only have to complete it one more time. So let's do it one more time. R, U, R prime, U, R, 2U, R prime. As you can see, our whole layer is now yellow. So I've gone through every single case. So if you need to, just go back into the video a little bit more and look for the case that you have, and you can complete the top. Now you can click anywhere on the screen and go back to the homepage and click on PLL.